All right, welcome back, fifth graders. This is Mr. Mace again, and we are continuing to multiply fractions. Now, we have a very specific kind of fraction today. As you can look at the top here on page 113 in your math expressions book, you can see that we are finding out how to multiply mixed numbers. And again, very similar to multiplying just regular fractions, which you've been doing for about the last 5 or 6 days, but there is an extra step or two. Okay, so just be aware of that. Very similar. We're going to build upon what we already know, but we also have to be aware that there is another step here. Okay, now I'm going to very lightly touch on this page because I almost find that this page gets to be a little bit more confusing for students than helpful. But we are looking at a girl here named Melinda, who is a farmer, and she has a rectangular field that is 1 2/3 miles long by 3/4 of a mile wide. And we need to find out what the area of that field is. Well, we know how do we find area as base times height, or length times width. And so we can see that we've got one side of her field, which is right here, and here's our 1 2/3. And you can see that she's got a width going this way of 3/4. All right? Now, as we look at the field itself, or how this is all playing out, it makes it really difficult to combine these two numbers, to multiply these two numbers together when we have different sized rectangles or different sized squares inside of here. So we really need to make it a common unit, kind of like we did with adding where we came up with that common denominator. Here we need to make sure that we don't keep the whole number separate. We need to make sure that we wrap that whole number back into our fraction and make our numbers only fractions when we multiply. And what we're doing there is we're basically converting that mixed number into an improper fraction. So if we look to the next example here, we take this 1 2/3 and we change that into the improper fraction version, which is 5/3 or 5/3. Okay, remember that we would go through that process like this. 1 2/3, I would multiply 3 times 1, which is 3, and then I would add the 2 on top, which gets me to my 5/3. So that is where I get that. And then obviously the 3/4 is already a fraction, so I don't need to do anything different with that. All right, and now I end up with an actual fraction times a fraction that I can multiply. I just really struggle, or we don't have the ability, guys, to keep our whole numbers separate and multiply them alone. We've got to make sure we combine them and we all keep them in the same form. In this case, it's going to be fractional form because there's no way for me to turn 3/4 into a whole number. It's going to have to stay that. So we got to get rid of that whole number by changing it into an improper fraction. All right, now as I get to this point, okay, I've got 5/3 times 3/4. I could just multiply straight across. I've got, just like we've been doing the last handful of days, 5 times 3 is 15, 4 times 3 is 12, and I can end up with 15/12. But again, whenever I see that improper fraction, I need to now convert it back into my mixed number form. Okay, so be aware of that as we go forward. Now, the last couple of lessons, or at least the last lesson, I know you guys have talked about simplifying first. Okay, about simplifying before I get to the end. So, or before I do my multiplication. So as I look at this, I should hopefully see some similarities here. And in this case, I can see a 3 and a 3. Those two numbers are identical, which means they'll obviously go into the same thing. And I can divide both of those by 3 to simplify that down to 1 and 1, which now makes my multiplication really easy because now I'm multiplying both the 5 and the 4 by 1. And so I could go right down to 5/4. 5 times 1 is 5, 1 times 4 is 4, and I could end up with my answer of 5/4 before I even did any multiplication. Pretty easy process there. Now, I'm going to show you that I'm going to end up at the same answer by doing this, okay? But for me personally, I would rather work with the smaller numbers than with the larger numbers. So 15/12, let's go back to our original. How many 12s can I pull out of 15? Well, I'm still going to get that one whole number out of there. What am I left over with? I'm left over with a 3. After I subtract 12 from 15, I pull those 12, that group of 12 out, I'm left with 3. And my denominator stays the same at 12. So 1 and 3 12s. Do the same thing for the 5/4. I end up pulling a 1 out. I'm left over with 1 as my remainder. and in this case it's over 4. Now you might say, Mr. Mace, that's still not the same. Well, that's because this mixed number is not simplest form yet. I can look at that 3 and that 12, hopefully, and recognize that I can divide both the top and the bottom by 3. So I'm going to bring that mixed number down here a little bit, and I should be able to see that if I divide both the top and the bottom by 3, I end up with 1 and 1/4, and those are the exact same answers there. So if I simplify before or if I simplify after, I'm going to end up with the same answer. It doesn't really matter. At least in my class, I know I don't really care. I know some teachers stress that more than others. All right? But there will be simplifying whenever you're multiplying of fractions. That really is going to be probably the biggest skill that you need to keep in mind. All right, that's all I really want to focus on that page. So let's turn our books at this point to page 114. And we're just going to start looking at some examples here. Now, like I said before, the most common mistake for people when multiplying fractions is they want to just multiply the fractions and then tack the whole number on to the end. And I'm going to show you why that doesn't work, okay? Why that isn't the best case scenario here. So as we look at problem number 5, we've got 5 6 times 1 and 1/3. Well, if I just want to separate the 1 and say I'm going to get to that later, or I'm going to make sure I bet my answer has a 1 in front of it, okay, and I multiply, 5 times 1 is 5, and 6 times 3 is 18, okay? Oh, that's simplest form. I've found my answer. But that's not how that works. So I really want you to understand that that is not the way we are going to try to solve that. I need to, before I do my multiplication, I need to convert my mixed number into an improper fraction, okay? So my problem should be 5 6 times, in this case, 4 over 3. And I get that again by multiplying the bottom number times the number up front. So 3 times 1 is 3, plus the 1 I've got on top, which is 4. All right? So this is my problem. Now, I could solve right now by multiplying straight across and simplify at the end, or I could look to simplify first. Look to simplify before. Well, 5 and 3 are both prime numbers. I know that 3 doesn't go into 5, so there's really nothing I can do in that way. But if I look at the 6 and the 4, if I look at this number and this number, they're both even numbers, and I think that I can divide both of those numbers by 2 and make this problem a little easier. I can change this 4 into a 2, and I could change this 6 into a 3. That's not a 5, that is a 3. All right. Then I multiply straight across. So I end up with 5 times 2 is 10, 3 times 3 is 9, and I've got a nice, easy, improper fraction that I can convert into my mixed number by simply pulling the one group of 9 out, having 1 left over, my denominator of 9. Okay? Now up on top here, I'm going to show you what I could have done without simplifying first to show you that I'm going to get to the same answer. So I originally started with 5 6 times 4/3. All right, multiply straight across, no simplifying first. 5 times 4 is 20. 6 times 3 is 18. Okay, now I could simplify at this point, or I could turn it into my mixed number at this point. Okay, 1 and 2/18. And then divide both the top and the bottom by 2. Gets me to my same answer of 1 and 1/9. This answer and this answer are the same. Okay? And that doesn't just go, that isn't the only thing we do if it's just a fraction times a mixed number. It is the same thing if we are a mixed number times a mixed number. Okay, so if I look at problem number 7 here, I've got 2 mixed numbers. So my original problem, I need to go through this. Let me erase this just to give myself some more space here and not seem so clustered. Okay, so 1 and 3/4 is going to be 4 times 1 is 4, plus the 3 is 7/4 is my improper fraction, times 2 times 4 is 8, plus 1 is 9 over 4. All right, now in this case, as I look to simplify first, as I look to cross those two things, 7 and 4, nothing's going to go into both 7 and 4. All right, also, nothing is going to go into 9 and 4. So in this case, I've already got this in simplest form, and no matter what my answer is, it's already going to end up in simplest form. Okay, so now I just got to multiply straight across. Well, 9 times 7 is 63. 4 times 4 is 16. Now notice this isn't like adding. Even though I have a common denominator here, the denominator has to be multiplied together. In adding, that would have stayed the same. It would have stayed a 4. But in this case, it's multiplying, so that denominator has to change to a 16. Now I've got to go through the process of pulling 16s out of 63. And again, there really is no easy way to do this other than just looking at the division piece, guys. So 16 times 2 is 32, so I know I can pull 2 of those out. Okay, 16 times 3 gets me to 48. That's still smaller than 63, but I think that's about as far as I can go, so I'm going to pull 3 wholes out of that. And like I said, 16 times 3 is 48. So now I have to subtract 48 from 63. Well, when I go through that process, I find out that I've got about 15 left. That becomes my new numerator. My remainder becomes my new numerator, and the denominator stays the same. So 3 and 15/16. All right. Now, it would have been nice if that one would have had a simplest form or a way to simplify that earlier, but in some cases, it just doesn't work that way. All right. I'm going to go across to problem 8, again, just to kind of show you one that I know will be possible here. So we got 2 times 4. To turn this into an improper fraction, I got the whole number 4 outside here. So 2 times 4 is 8 plus the 1 is 9 over 2 times 4/5. The 4/5 is already there. Now again, I know that 9 and 5 can't be simplified, but I do know that 2 and 4 can. They're both even. So if I divide them both by 2, this becomes a 1. This becomes a 2. 9 times 2 is 18. 1 times 5 is 5. Okay, still have to convert that into a mixed number. Still got to be able to divide 18 by 5. So this is what this looks like. 18 divided by 5. How many groups of 5 can I pull out of 18? I can get 3 of them. So my whole number is the answer to my division problem, 3. After I go through the long division process, I realize that I've got 3 as my remainder. So that becomes my new numerator. And the denominator does not change. All right, so 3 and 3/5 should be my answer for that one. All right, now I'm going to quickly go down here. I got a couple minutes left before my time runs out. Doesn't change when we're talking about word problems, guys. And again, since we are dealing with only multiplying, really kind of an easy process here. Identify what the question is. In this case, it says, what is the area of the pen? We know that that is base times height. In this case, they don't tell us which is the base and which is the height. That doesn't really matter either. Okay, so we start with 2 and 5/6 times 1 and 1/2. First step in this process, I have to convert this to an improper fraction. I got to multiply fractions by fractions. I can't have whole numbers. So 6 times 2 is 12, plus the 5 gets me to 17/6, times 1 times 2 is 2, plus 1 is 3 over 2. Now again, I'm getting some pretty large numbers here, so I'm going to look to simplify first. 2 and 17 are both not even, so I can't divide those both by 2, but I can look at 6 and 3 and realize that the same number will go into them. I'm going to divide them both by 3, so that 3 divided by 3 becomes a 1. 6 divided by 3 becomes a 2. And so I end up with 17 over 4. And then I've got to convert that into an improper or a mixed number from an improper fraction. So 17, this fraction bar doubles as a division symbol. 16 divided by 4 means I'm going to pull 4 whole numbers out. I'm left with this as my remainder, so that becomes my new numerator, 4 and 1, and my denominator stays the same, 1/4, and in this case it would be, because I'm looking for area, square yards. All right? All right. So again, guys, I know I'm going through this kind of quickly. Please make sure you're asking questions of your teachers as you get to that point. All right, I'm looking at one here. I'm going to jump down to question number 13 because I only have to change one of my fractions, or one of my mixed numbers to a fraction, and that is a bucket. How much water is in the bucket? So we need to multiply these two things as well. 2 and 3/4 times 5/8. So I need to convert this one to a fraction first. In this case, it'll be an improper fraction. 4 times 2 is 8, plus the 3 is 11/4 times 5/8 is already there. Now in this case, none of these numbers can be simplified before. 5 and 4 don't go into each other. 8 and 11 don't have the same factors that go into it, so I'm simply multiplying straight across. 5 times 11 is 55 over 8 times 4 is 32. All right. Then I need to convert this to a mixed number. How many 32s can I pull out of there? I can pull 1 out. And then I subtract, since I only pulled 1, 55 and 32, which gets me to 23 32s.